All right, in this video we look at a little bit of review from geometry, but what we're going to look at has direct applications to pre-calculus that we're studying right now, and that is the trig ratios for special triangles. In geometry, you may have learned that some special ratios for 30 degrees, 45 degrees, and 60 degrees in a right triangle. What you also should know is that 30 degrees is the same as pi over 6 radians, 45 degrees is the same as pi over 4 radians, and 60 degrees is the same as pi over 3 radians. I will do everything in terms of degrees, but those are directly translated into radians. The first one I want to look at is a 45, 45, 90 triangle. Over here I've drawn a 45 degree, 45, 45, 90 triangle. It's a right triangle. Okay, if the angles are equal, then these two legs are going to be equal. So this will be A and this is A. And then using the Pythagorean theorem, I can find the hypotenuse. Okay? So if I have this 45 degree angle and I'm looking for the sine of this angle, the sine of the angle is equal to the opposite side over the hypotenuse. So from here, 45 degrees, opposite side over the hypotenuse. A over the square root, A times the square root of 2. Okay? If you reduce that fraction, you get 1 over square root of 2. We really don't like radicals in the denominator, so I'll rationalize the denominator by multiplying by square root of 2 over square root of 2. Simplify that, and it gives me square root of 2 over 2. So the sine of 45 degrees is exactly equal to the square root of 2 over 2. Cosine of 45 degrees is the adjacent side over the hypotenuse. So the adjacent side is A, the hypotenuse is A times the square root of 2, just like the sine. So that simplifies exactly the same way to square root of 2 over 2. So the cosine of 45 degrees is the square root of 2 over 2. The tangent of 45 degrees is equal to the opposite side over the adjacent. So 45 degrees, opposite side over the adjacent, A over A, which equals to 1. So the tangent of 45 degrees is exactly equal to 1. So let's move on to the 30, 60, 90 triangle. To do this, I've created an equilateral triangle where all the sides are 2A. Okay? And that makes all the angles equal to 60 degrees as an equilateral triangle. If I drop an altitude from the vertex to the opposite side, this will bisect this side. So if it was 2A for the whole side, then this side is equal to, just this side is equal to A. So I have A, 2A, and now I need to find out what's an expression for the altitude of the triangle. The altitude of the triangle, using Pythagorean theorem again, 2A is the hypotenuse. So B squared is equal to the hypotenuse squared minus the opposite side squared. So 2A squared is equal to 4A squared minus A squared is equal to 3A squared. So B is equal to A times the square root of 3. So that's what this side here is equal to. So now let's look at this angle right here. The sine of 30 degrees is equal to the opposite side over the hypotenuse. Sine of 30 is equal to the opposite side over the hypotenuse, which reduces to 1/2. The sine of 30 is exactly equal to the cosine of 60. So these two angles are co-function angles. So cosine of 60 is also equal to 1/2. Cosine of 30. Cosine of 30 is equal to the adjacent side over the hypotenuse. Remember, this B is equal to A times the square root of 3. So the cosine is equal to A to the square root of 3 divided by 2A. Reduce that fraction, you get cosine of 30 is equal to the square root of 3 over 2. That's also the same as cosine of 30 is equal to the sine of 60. Sine of 60 then is also equal to the square root of 3 over 2. The tangent of 30 is equal to the opposite side over the adjacent side. So the opposite side is A. The adjacent side, which was B, which is also equal to the A times the square root of 3. Simplify that fraction, get 1 over square root of 3. Again, rationalizing the denominators, multiplied by square root of 3 times square root of 3 over square root of 3, simplifies to square root of 3 over 3. So the tangent of 30 degrees is exactly equal to square root of 3 over 3. Tangent of 60 degrees. Tangent of 60 degrees is equal to the opposite side over the adjacent side. So the opposite side is b, which is equal to a times the square root of 3, over the adjacent side, which is a. Simplify that fraction, and you get the square root of 3. So the tangent of 60 degrees is exactly equal to the square root of 3. So I'd like to summarize this, and if you can learn this table, this will make your life a lot easier for trying to memorize these things. We will fill in these 6 squares in the next video, but for right now, look at what we have here. The sine of 30 is equal to 1/2. That's also equal to the sine of pi over 6. So the sine of pi over 6 is equal to 1/2. If you notice, sine increases, goes from 1/2, square root of 2 over 2, square root of 3 over 2. So we need to figure out what these two things are. Cosine does the opposite. Cosine decreases from the square root of 3 over 2, the square root of 2 over 2, 1/2. Tangent increases. Tangent, we'll learn in another video, is just the ratio of this divided by this, but we can also prove it using the 30, 60, 90 triangle. The tangent of 30 degrees is equal to square root of 3 over 3, and you notice these increase. Tangent of pi over 4, square root of 2 over 2, divided by square root of 2 over 2, which is equal to 1. And the tangent of 60 degrees is equal to square root of 3 over 2 divided by 1/2, which is equal to square root of 3.